Okay, now that we know the overall flow of control in a processing program in active mode, it's time to talk about user-defined functions. The goal of having user-defined functions is to have a very organized and maintainable program. If you have all your code inside your draw and inside your setup function, then those functions are going to get huge and they're going to be really difficult to read, maintain, and change. Therefore, although that program with all your code in your draw and your setup, it will run, it's not going to be a very clean and cut program. Therefore, in order to have an organized and maintainable program, we need user-defined functions. That is, we're going to break up our code into smaller chunks, and these functions are going to be the building blocks to our program. Essentially, you want your setup and your draw function to only contain a few lines of code. So your setup and draw will actually read like pseudocode in such a way that there is no mathematics, there is no extra processing stuff inside your draw and your setup functions. So in order to make that happen, let's look at a user-defined function and let's see what we need in order to make a user-defined function. So as we said before, a user-defined function essentially has, so if this is a function, it's going to have input, a number of inputs actually, and it's going to have one output. Now, when I say input and output, I actually refer to data. So when I say input, it's data going into the function, and output, data coming out of the function. So these are both in terms of data. So a function can take as many as you give it in terms of inputs, as much data as you can give it, but it can only produce one output. Right now, the functions that we're looking at are called return functions that return by value. So functions that return by value, and we're going to study them this week. When we talk about arrays in the following weeks, we're going to look at another type of functions. But this function is a function that behaves this way. It takes as many inputs as you give it, and it'll produce one output in terms of data. So in order to have a function, then you're going to need a function block like that, where in your block you're going to have a bunch of, like all your code that you meant to put inside your function, right? So number one, you need your function body. That's what it is, or your function block. This is your code block. The second thing that you're going to need is actually the name of your function. So what are you going to call this? So let's just call this function sum. You can call a function anything, but it is advised that you find a meaningful descriptive name for your function. So this is number 2, is the name of the function. And then there are two other things that you need. So first of all, you need the inputs. So this is number 3. Number 3 is you need the input going into the function. So let's say we are going to have two integers named a and b as input, and the last but not least is the output of the function. So number 4 is the output of the function. And in this case, I'm going to say that I am going to want an output to be a integer. So here for the output, you're not actually writing the variable that's going to be the output. You're actually going to write the type of the output, right? So give these some actual computer names. This is called the return type of the function. So you're going to say, what is the return type of this function? This function is going to return an integer when it's done its processing. When it's done, it's doing what it's doing. And these two, the inputs, are actually called parameters. So the parameters of the function has two parameters, a and b. So basically this function, it has, so this is function sum. It has inputs a and b going in, and then the variable name that's coming out, we're going to establish that, but we know that it's going to be an integer. So let's write the body of this function. So if I wanted to write the body of this function, for example, this function is function sum, so it's going to add the two values, for instance. Like that's what I'm writing. So if it wants to do that, then I could have a variable called, let's say, result. Result would be equal to a plus b. And then I need to send this result to whatever function that calls our sum function. So I'm going to say return. So return is a keyword. So remember, we have the return type. So I'm going to have return. And what am I going to return? I'm going to return result. So here, the output is result. When a function calls sum, it's going to get result back. So for example, in processing, we would have something like this. Let's say we have our setup function, and in setup we have int x as 5 and y as 8, and we are going to have and if we want to call our sum function, so I'm just going to quickly write sum function down here, and it's going to rewrite we had int a and b, int a and int b, and then I had int result, and then I had result a plus b, and then I had return result. Okay, so in my setup, so if I run this program right now, nothing happens, right? If my setup, if I want to call sum, so for example, I would say int res variable, and I would call sum. In order to call it, just like calling a person, I would call sum. And just like calling any function, just like calling the rectangle function, the rect function, the ellipse function, what I would need to do is I would need to provide it the input that it requires. This function requires 2 integers. So if I gave it 1 integer, it'll give me an error. If I try to give it 2 doubles or 1 double, it'll give me an error. It only works if I give it 2 integers. So I could say x and y. So I would call it and it would give it 2 values. And down here, if I said print ln res, this would output 13, which is maybe not so lucky, but that's the answer, 5 plus 8. Let's draw the memory diagram for this and let's see how this actually works. So basically the program, don't forget, the program starts from setup. The program, the processing goes to setup. Then if there is a draw, it goes to draw. If there is not a draw, basically the program ends. So if there is no draw, if you don't call sum, the program is not gonna go into sum. So it'll be like this. So you're going to have setup. In setup, we have x and we have y. X is 5, y is 8. Then we come here and we have res. So we have res, inside of res, we have garbage. Then we call sum. So sum is going to appear. So we have not exited setup yet. We have given control to sum now, right? So we have given control to sum. So here is sum. So here, let me just draw this the control of this program. So here is start. We have setup, right? And now control from setup has been given to sum. So we are here right now, so the flow of control is going to be here, and then when we're done with sum, we go back. So that's where we are. So setup it has not been destroyed yet. So what happens is we go to sum. Sum, you see, it has parameters. Okay. So the memory of sum is going to be divided in two. The bottom part is going to be reserved for parameters that are coming in, and the top part is going to be for local variables, right? So it has two parameters coming in, A and B. So we're in this line right now. We are at the very first line of sum, and sum, when it's called, two values are being passed. It doesn't matter what these values are being called, it's that the first value that's being passed is going to be copied inside the first parameter. The second value that's being passed is going to be copied into the second parameter. So whatever x is 5 is going to be copied into A, y is 8, and 8 is going to be copied inside of B. Then we're going to move to this line, int result. So we're going to have a local variable called result, inside of which it's garbage. Then we're going to do this line, we say result equals a plus b. So a plus b is going to be copied inside of result, the result of it, so 13. Then we say return result. When we say return result, result is actually going to be returned back to here. So you see, when we call this function, we basically say that the result of this function, whatever this function returns, should be stored inside of this integer. So when we say return result, the value of this result is going to be thrown back and it's going to be caught by res. So sum basically throws its results into res. So res will become 13. One more thing that happens is that as soon as we say return in a function, in any function, if you say return, that function terminates. So now sum dies, and this is what we are left with. And then we get to here, since there is no draw, this function dies as well. So let's go back here and actually make a more complete model of a processing program in active mode. So this sum comes back here. After setup, you basically have a choice. Is there a draw function? If no, the program ends. If yes, we go into draw. And you recall from draw, is window closed? If no, we keep going back to draw. If yes, the program ends. So that's how the model works. If you have functions inside of draw, you're going to have the same thing as you have with sum up here. This is where the model actually is, and this is how it works. So let's have a quick look at setup. So if you have void setup, and setup has a whole bunch of lines here, you should have noticed something very, very important about setup and draw right now. It's because setup and draw are functions as well. They have no difference. So like if you recall, if you have function int sum, and sum has an int a and an int b, and it has a whole bunch of statements. These aren't very different. They're the same things. If you're going to draw a model for this, you see that sum, in terms of data, it has data going in and it has data coming out. Hence the return value. The return value of there's a return value. So you must have you must send back an integer with sum. But setup, it has no data going in. It has no data going in, and it has no data coming out. That's what void means. Void means that there is no data coming out. I mean, I'm going to talk about this a little bit more, but what I want you to pay attention to here is that setup and draw, in terms of input going in and input coming out, meaning data going in and data coming out, they have no data going in and they have no data coming out. So more about this and what the return and more about the return value in the next lecture coming up. Thanks.